Okay. Actually, in this session, I want to talk about LRK Proxy module in Kamailio and integrate the LRK Proxy with the concept of game theory in terms of conception resource allocation while using multiple Kamailio server and one LRK Proxy media server. Before I want to start my presentation, let's talk about who am I. Actually, I am a PhD student in Mashhad and web counsel and software engineer. I have 50 years experience in developing web soft switch like Asterisk, like Kamailio, like OpenShips, FreeSwitch, acquired Bit and Kazo. Mr. David, I wrote a book about the asterisk in Persian language. It introduced by yourself in asterisk conferences, and I have a BCAP certificate from asterisk and Digium company. And now I am a member of Kamailio developer because I have developed a two module for Kamailio, LRK Proxy and HI Ops, handover interface operations. Okay, let's kick off. What is LRK Proxy and what is the game theory in related to LRK Proxy? The LRK Proxy is a kernel RTP media engine for relaying RTP packets processing an IC in your network. For example, the LRK Proxy architecture is composed of two different layers. The first layer is LRK Proxy control layer, or CL, is the first layer that is developed as a user space in a 7-layer in the OSI model or application layer, and the second one is developed as a Linux kernel module in kernel space application in Linux operating system. The main decision point for RTP admission control and quick path selector and relay the RTP packets to another user equipment. What is game theory? Actually, the complex system needs a powerful strategic interaction between self-interested agents. The game theory is the concept to provide a model for presenting the strategy interaction between players. The players are self-interested agents. In these terms, I mean the Kamailio server or our player in the game to compete for getting more resources from LRK Proxy for their self. I will talk more about this player and strategy. Each player, for example, Kamailio server has a personal information or personal configuration. How many RAM does they have? How many resources does they have? And the personal interest, for example, a number of concurrent calls in the app. For example, you have a multiple Kamailio server, and depend of each configuration, they want to raise the number or amount of current calls for itself. Probably the player might not report their own personal interest trustfully. For this would be happen for getting more resources. In the system of model, the player or the Kamailio server because they would to have a compete with each other to get more resource from LRK Proxy for having more resources. Each Kamailio server has a specific configuration. They must commute with LRK Proxy for relaying the RTP media for their calls. The strategy of each player is the requested more available resource. Actually, I mean available free port range that are available in each media engine. The payoff or profit for each player is having more available port for doing a more concurrent call, because when a call is set up or established, you know, and everyone know, 4 ports are reserved for doing RTP relaying in a session. The solution of this game will lead to Nash equilibrium or Nash point with respect to John Nash between the player in competition. Non-cooperative game theory. In each media engine, we must specify the range of ports. In maximum case study, we could use 50,000 available port. For example, we started from 10,000 up to 60,000. And for each voice call, 4 ports are assigned. 2 ports for send and receive RTP packets between the LRK proxy or media server and between the user equipment. And 2 ports are reserved for real-time control protocol and controlling protocols. And now would rise this question: how many calls does the media engine could handle? Let's answer this question in mathematical theory and the real world situation. For example, we have started available port from 10,000 up to 60,000, and we have 50,000 available port in our schools in media server. For example, you could use RTP proxy. You may use an RTP engine or other etc. For example, Asterisk or Free Switch, that you specific range of ports that should be reserved for relaying RTP. In maximum situation, we divided to 4. We have 12,500 concurrent call in a maximum call in the mathematical theory. As you can see here, the number of ports makes limits for us to increase call traffic capacity. It's not too big. Maximum call in the real world solution. We know 2 important factors that increase the consumption of resource in the network. How many calls per second you probably have in your network, and does your network is anchoring and relaying RTP itself or not? Because relaying RTP could cause the increase the consumption of resource. In the real world, for one server with not very powerful server, actually I means, you probably could handle 2,000 or 3,000 or 4,000 call. Depends of the list, the material of list that you probably have in your network. And in the mathematical, it is very clearly the maximum call in the real world is too less than the maximum call in the mathematical. Yeah, it is really clearly. So, how can increase the number of RTP sessions in the system of our model? For example, suppose we have more than one Kamailio server in network, in system of models, and we want to use just one media relay in a system of our model. So in the real-time world, what is our solution to increase the number of RTP session in our network? In the real world, absolutely, you should use more media relay server for and use load balancing. Probably use a dispatcher module in Kamailio for having load balancing in your network. Absolutely, you should pay more money to have more resources and server and establish a new instance of media relay server in your network for having more RTP session relay. In the mathematically, to overcome the limitation, because we have the restricted range of ports, you probably have to use more IP, and each additional IP gives you 20,500 more cards, because each IP, when you use one IP, you could use all range of ports again. And what is the best response in the game theory? The game, in my opinion, the best response is using LRK Proxy Architecture. Yeah, as I mentioned before, LRK Proxy is composed of two different layers. The first layer is developed as a module in a Kamailio, and you have to use this module in your configuration file and load a module and set some parameter for installing the LRK proxy. The second layer is a different service. You have to install it in your operating system, and it could be kind of a Linux module in your operating system. You probably install it in the same Kamailio server or in different Kamailio different server in your network. The first layer gets all information from Stiffy body during signaling and relay them to the next layer. As you could see here, when a session call, or when you make a call, this command is received by the LRK proxy with some information from STP during signaling. For example, where is source IP, where is destination IP, and where is the snap IP, where is the NAT IP, and some other etc. more. And the call ID, it's a unique ID in your transaction Kamailio. This information goes to the LRK proxy engine with a LibNet library for doing or moving or sending some information from a user space kernel, user space to kernel space. And we could use a library for sending some information to kernel space in Linux. The second layer is the main point for RTP admission control, and receive packet should be forward with the power of pre-routing in the Netfilter hooking. For example, when we send this information in LRK proxy engine, based on the packet from where and from what is source IP, what is port, and what is about a destination IP. The packet forwarded to the next station or destination. This forwarding would be run in the 3 and 4 layer in OSI models. And do not need to, the packet goes up to 7 layer in OSI model, and in that layer relay and switch to the next station and goes down to physical layer and go to the next destination. This is a simple configuration from LRK Proxy. In Kamailio, you have to load LRK Proxy and, for example, LRK Proxy socket for connecting with LRK Proxy engine, and some custom variable may be used in your configuration file. And right section, you could use a simple configuration from a LRK Proxy engine. For example, a start port, for example, an endpoint, and other etc. Communication. Okay, what about a GT or a binary option config in LRK Proxy? Look, this option could be set by 0 or 1. The default is 0. And what will happen if is set by 0 or 1? Okay. Suppose we have the default value is 0. In the normal call flow solution, when one user equipment calls, the invite comes to asterisk, come to Kamailio. Kamailio forward the invite packet to the next destination. For example, in this soft model is a user equipment 2. The media port is set to 20,000. And when the user equipment pick up the call, it sent 200 is okay, 200 okay. And Kamailio set the next available port for relaying the RTP between user equipment 1 and user equipment 2. Yeah. Now, we set this option to 0. We could use the same port in each part, 20,000, because we could use this option in the game theory strategies for having more available port that is caused to having more concurrent call in your network. Let's talk more about these conditions. When we get some information from the first layer and send information of make call to the second layer, we create keys with a triple of data. For example, UDP destination, UDP source, and IP address source. We create hash code and the index of the buckets. We save the address of the next destination. You could see here hash of triple data and goes to the buckets, and we could found the next destination. For this reason, we could use the multiple use port in this situation. For example, it's a kind of data that I receive in the LRK proxy second layer. We create a net state message and save some parameter to this variable and create a hash. And create another hash index for reverse direct for sending and receiving data, RTP data. Yes, in the pre-routing Netfilter hooking, we have two famous functions, main hook pre-routing and main hook post-routing. In pre-routing, we just change the destination address to the next user equipment. After that, we have to update the checksum. And the post-routing, we have to update, for example, SNAT to its LRK proxy IP and destination, and source to next destination, and have to change and update the checksum. Yeah, the LRK proxy second layer is placed in a pre-routing module in Linux. After updating the packet goes and the routing decision block and goes forward the next station. Okay, this route is offloading CPU because we know have used more using CPU for forwarding. Multiple LRK proxy second layer configuration. LRK proxy first layer and second layer could be run as an independent function on different machines. We could have one LRK proxy module and multiple LRK proxy engine with different machines. It is possible, and it is possible to do not lose sessions when one LRK proxy engine crashes, because all data that from a LRK proxy engine could be saved in the shared memory. For example, in this here, we use HCD for having a sharing distributed between LRK proxy engine. It's under development. And the second one, we have multiple Kamailio server and one LRK proxy server. Each Kamailio try to catch most available range port from LRK proxy. LRK proxy could use all range resources port in LRK proxy TSL. As you could see here, this Kamailio could be in the right condition for having more resources from LRK proxy. Yes. Changing SDP parameter will be done by Kamailio with the game theory strategy and not by LRK engine. Each Kamailio change the SDP itself, STP parameter itself, and not by LRK proxy for send all STP information to LRK proxy engine. LRK proxy engine change all parameter and send back to Kamailio, and Kamailio have to paste in the packet. Forwarding a packet in LRK proxy is in pre-routing hook in Netfilter hooking. LRK proxy support NAT traversal for endpoints with custom STP information by attribute value pair. RTCP LRK proxy support RTCP. We could use a resource port allocation with algorithm of game theory for using port in RTP session. We have to enable forwarding options in your operating system. Unfortunately, already we do not support transcoding in LRK proxy because we focused on the huge number of packets that comes to your network. With LRK proxy, could make anchor to target RTP for lawful interception under development with HIOps module. It is our paper that was published in IEEE. You could see more information about this. And let me share a Wireshark packets. It is a sample call. As you could see here, the call is generated from user equipment, goes to Kamailio, in Kamailio after some checking and by user agent with XAMPP, we delivered it to the next destination with LRK proxy, as you could see here, and we reserve 20,000 port in this here, and let's go to device OK, 200 OK. 200 OK, no, buy and also we use the same port in the 200 OK in Wisconsin. Okay, thank you very much for this opportunity.